everyone. I'll talk in English, and we're going to talk about the IaC tooling Multiverse and the future of platform engineering. So we all know this diagram, probably when we learn how to software develop. That was our architecture, some web server with a database behind the load balancer, and that was pretty much enough. What we sold was pretty simple, and we didn't have a lot of our cloud infrastructure to use. But today it looks more like this, very complicated, very complex. Our products and issues became much more complex, and with that, everything the cloud will give us, and we want to use it. So today we have VPCs, we have those internet gateways that we wanted to use, we had internal gateways that communicate between each other, we have S3 buckets that we want to implement, we have some instances that are running inside, and some firewall to make sure that no one tries to hack us, and we need some way to manage all of this. And before infrastructure as code, it looks like this. We need some document to tell us what to fill and in which form. So it tells us, go to the bucket and fill those information, now to choose an API type, press on those buttons, how to launch an instance. So it becomes very, very complicated to do, and we need a way or a manual to keep those. And the issue is that those manuals are become outdated pretty fast, and instead we can just do it in code. A lot of smart people came and told us, hey, we're all developers, we all know how to work, why we need those long documentations. Instead, let's write it in code. So who am I? I'm Eran Elbaz, or just Elbaz is enough. I'm a full-stack developer at NF0, and I'm a former OpenTofu core team member, and we'll talk about OpenTofu in a bit. And the agenda for today's talk is, why do we need infrastructure as code at all? How to choose the right infrastructure as code tool, because we have so many. A bit on our organization infrastructure as code maturity, and a bit about DevOps process and the unified way we see it. So a small story time that we have. We're on call in some company. For those who don't know, on call means that if there is an issue in 2 a.m., they call us, which what just happened. And we need to gather our coffee, turn on our computers, and start looking at all the graphs and understand what's going on and why they called us. And we start digging and doing our research, looking at logs, metrics, and so on. And suddenly we have the solution. We found that just ticking that settings or raising the memory can help us until the morning and making sure we can go back to sleep, because that's all we want at 2 a.m. And this is what we do. Next morning, we go to the office, talking with our team members over coffee, maybe submitting a ticket to R&D, making sure they will research and fix that issue. But what we forget to do is to update that long document that it talked about, or making sure that all our clusters are in sync, because now we have, for example, production A. Maybe we are on high availability. We have production A that now have this setting on, while our disaster recovery doesn't have this one turned on. And next time someone will come to make a change, this person will be like, hey, there's an issue here. No one documented this change. We don't know why we did it. And those are the issues that we have before having infrastructure as code. And the rise is meaning that today infrastructure as code is the de facto standard for managing our infrastructure, because it's very easy to deploy the same stack over and over. Again, that's a code. We can just run it again and again to different regions, different accounts, and making sure that everything is synced. We, of course, ensure alignment between all the stacks, because, again, that's a code that can be auto-deployed everywhere. And we can enforce consistent standards across all environments, because that's code. Again, we can make sure that people look at it, making sure that the new modules that we introduce are the same as the previous ones, No one needs to review those long documents and making sure that, hey, it's in the same format, and we can run some automation over it. And by doing so, we can make sure that everything is scaled as we want, and we are consistent throughout our entire infrastructure. So the challenge basically is choosing the right tool. We can see we have many since '93, up until 2 years ago that we introduced OpenTofu to everyone. And there is a turning point, meaning instead of having the how we want to introduce new infrastructure or provision new resources, we can now just say what we want. For example, in Terraform, which today is considered to be the industry standard, we can just say, hey, I want this EC2 instance or this database with that spec, and it will handle everything for me behind the scene. I don't need to make sure that, hey, if it exists, I want to do that. If something changed, I want to override it. It do it for me. And choosing the right infrastructure as code tool is a complicated task because we need to make sure it stands with our security and compliance of our organization. If we need to store some sensitive data, we want to make sure that our infrastructure will support it, and we won't have any data leak. We need to make sure it will scale with scale with our performance, because we don't want any infrastructure as code tool that hinder our organization performance. And we need to make sure that the learning curve and adoption is fairly good for us. We don't want to introduce something in C, for example, if we're writing in JavaScript. We need to make sure that our team will be able to learn that or is pretty good with our current standards. And now I'm introducing you to the battleground. So in the left side, we have Terraform. Today, again, it's the industry standard. Probably most of you are familiar with it. It's cloud agnostic. If I'm using AWS, GCP, I can use it. It also has a way provider to connect to Pizza Hut if you want to order a pizza. It has a large ecosystem and community, so if you encountered something, probably someone else already encountered it. But the issue, for example, is that there is no state encryption by default, and there is a lot of state override that we need to handle. And we use HCL, which is a proprietary language, HashiCorp language that we need to learn. And maybe if we need something small that we are not familiar with, that might be not the case for the tool for us. And on the other side, we have AWS CloudFormation. It's using YAML and JSON, so I guess we're all familiar with those configuration languages. And by the name, it has tight integration with AWS, which is something good, but it's also something bad, because if we are on multiple clouds, maybe that's not the tool for us. Next, we have Pulumi. We can use our languages that we already familiar with it. Maybe it's TypeScript, Go, Python, and so on. It's also cloud agnostic, but there is only the default state management. So if we are on self-hosted way, we cannot use it because we have no way to host the state. And the community size is fairly small. Next, we have OpenTofu. It's a drop-in replacement for Terraform. So if you're using Terraform, you can also use OpenTofu pretty easily. It's a true open source by the CNCF, so you're not bounded to any company. There is a better state handling capabilities that was introduced by the community, for example, state encryption. But it's relatively new, and the community is fairly small. Next, we have also Ansible. We're using YAML and Pythons, again, languages we probably all know of. We use it to publish changes to our clusters, and it's agentless, meaning it will connect to your servers and will configure them, but there is no state management. And next, we have Crossplan that some talks already talked about. So it uses Kubernetes manifest syntax, and it's cloud agnostic, but you need Kubernetes. So if you're heavily into Kubernetes, maybe that's good for you, but if you're fairly new with it or not know everything, it might be not the case. So who won? that's a hard question to answer because there is no best infrastructure as code tool for all scenarios. The winner depends mainly on what platform are we using, where are we deploying to, and what technologies are we all familiar with. So why not use both? Let's choose multiple tools. We always can use the benefit of combining multiple tools together. Then we can leverage strength of each infrastructure as code, similar to microservices, that we can choose the language that is relevant for the service based on the task. And we can address diverse requirements. And we can align with the tools that each team might know and need. And of course, we can always consider using some in-house scripting if there is some spatial need. For example, in N0, we use OpenTofu, CloudFormation, and serverless. So we use many, each for its own use case. And I want us all to understand our infrastructure as code maturity. We have the first phase. We're a small organization. We're fairly new to the cloud. We don't have many deploys. And maybe using that long document and what we call ClickOps is fun with us because there isn't a lot. We're a small team and small infrastructure. Then we find the spot where we begin to being slowed down by it. And this is the place where we would like to introduce infrastructure as code and automation on top of it. Maybe using our Jenkins or GitHub Actions to deploy those to the cloud and start to introduce infrastructure as code. Then that's also not enough because we need better governance or policies. And this is where we can start using some managed self-service solution that will give us much better cost control, governance, and automation on top of infrastructure as code. And how we see the unified DevOps process is that we are writing a code using, let's say, Terraform or OpenTofu. It doesn't really matter. And we push it to our version control. Next, we can trigger some CI/CD tool. And we can run, and I will touch on some tools here. We can use InfoCost, for example. This one will look at our Terraform configuration and plan, and will tell us, hey, based on those changes, you're going to pay $100 more each month. Or Chekhov that can tell us, hey, based on your configuration, you have some security issues here. Maybe you created some S3 bucket that opens to the to entire world, and this is probably not what you want to do because that's a security risk for you. Next, we can take everything and ingest it into Open Policy Agent. This is another tool that can read JSONs and tell us if those stand in the correct policy. So similar to how infrastructure as code codify our infrastructure, we can use Open Policy Agent to codify our policies. Then we apply the changes, and we can start to monitor them and make sure that everything is OK. So in summary, there is no single best infrastructure as code tool for all scenarios. The winner depends on your organization, maturity level, technology stack, and use cases. We need to adopt strategic and adaptable approach, meaning if we find that we need some specific tool for a specific case, let's use that and not try to abuse the tool. And just as when we were kids or our kids, they won't be satisfied by one game. They will try to use all the games that they want to make sure that they are happy. And thank you.